this size? Yes or no? You need to integrate it from one of its end to the another end.
So minus L by 2 to L by 2.
Yes, exactly. The limit will be minus of L by 2 to plus of L by 2. Okay, calculate it, everyone. And tell me the answer, that what do you get?
Two ml square by 24.
2m L square by 24. So it will get reduced to ml square by 12. Yes or no?
Oh, yes, sir.
Yes.
That will be m by L. And if we'll integrate this r square, we'll get r cube by 3. Yes or no?
Yes, sir.
From the limit minus L by 2 to plus L by 2. So can I take 3 out of it? Because this is unnecessary making the calculation tedious. So m by 3L into r cube, going limits from minus of L by 2 to plus of L by 2. Just place the limit inside it. You will get it as m by 3L into L cube by 8 minus of my okay, let me write it properly, otherwise you people will get confused. This minus of L by 2 whole cube. Yes, till now have I written everything exactly correctly? Yes or no?
Yes, sir.
Yes, sir.
Then what to do next? M by 3L into the first one will evaluate as L cube by 8. L cube by 8 minus of, this will be minus of L cube by 8. Yes or no? Yes or no?
Yes,
Yes,
sir.
sir.
If we'll cube the negative number, we'll get a ultimately overall negative number. So that will be m by 3L, and inside it L cube by 8, and this minus minus will get added up and will get L cube by 8. Okay, and that will be m by 3L into 2L cube by 8. So if we will just cancel out the things, you will get 2ml cube by 8 threes are 24L. And now let's start the cancellations. 2, this will get square, and 2, 1, and 2, 12. So ultimately you will get the answer to be m L square by 12. Yes or no? Yes
Yes,
or
sir.
no? Moment of
Yes,
inertia
sir.
of a rod passing through its center. Okay, we had seen that we are getting the different moment of inertia on uh, uh, getting on taking choosing the different axis actually. Okay, so this can say the same question can be asked to you for several other things as well. Okay, let me say that suppose if the rod was here, and what somebody says that this is the rod, and this time you need to calculate the moment of inertia, let's say about a random axis, not so random. Let's just give some distances, that this distance is L by 3. And if this whole length mass m at length L, so what is this length actually? Yes, what is this length? What is this length? L minus L by 3. Yes or no? If the whole length was L, so just reduce the L by 3 from it, you will get it as 2L by 3. Now this time you need to integrate it from minus of L by 3 to 2L by 3. Yes or no?
Yes, sir.
Okay, so this is something that you must know about the moment of inertia of the axes. So I think now we had started the moment of inertia of the continuous bodies, and we'll see the same things. We'll continue the same thing in the next class. So let us leave it till here only. And if there is any kind of doubts in this, so just ask me, or else that's enough for today. Then we'll have the next class next day. Okay.
Thank you, sir.
Okay. Okay. You're welcome.
Thank you, sir.
Thank you, sir.
Okay. Welcome.
Yeah, good evening, Jovita. How are you? Am I audible?
Yes, sir. Fine.
Yeah. So let's start quickly with the questions of reactions of aldehyde ketone and carboxylic acid derivatives. Got it? So let's take some questions and so let me quickly share the screen and I hope you can see the screen. And let's start with the so you are aware of Wolff-Kishner reduction, Clemmensen reduction, and a same question asked in NEET examination. So during the reduction of aldehyde with hydrazine and potassium hydroxide, the first is the formation of during the reduction aldehyde This is a general way to write aldehyde with hydrazine. So which reduction is this? And potassium hydroxide. The first is the formation of RCH double bond N NH2. Option B, R C triple bond N. So which option is correct? This is which reaction? Jyovita, could you name it? Just try to recall. Or we can discuss it quickly.
I don't know.
This is option. Is this the doubt?
Yeah.
Which question is this? Yeah. Yeah, Jaslyn. Could you just I and Jovita were discussing this question, just try to check which is this reaction. Aldehyde and ketone can be reduced completely, okay, by two methods. Those two methods are parallel to each other, okay. Parallel means any one of them can be used. One uses basic medium, another uses acidic medium. One is a Clemenson's reduction, okay, which uses zinc amalgam and HCl, which is the acidic medium, and aldehyde and ketones are completely reduced, okay. Or the other method is Wolff-Kishner. In Wolff-Kishner reduction, we use basic medium. We treat the aldehyde or a ketone, okay. This could be an aldehyde if it is H, or a ketone if it is some alkyl group. With hydrazine. Got it? And base. Hydrazine and base, we heat it strongly around 200 degrees. So that also will change this C double bond O2 CH2. Okay. With hydrazine, so this is the same question which is talking about the reduction of aldehyde using hydrazine and base, but that reduction doesn't take place directly. First, something is formed and that reacts with base to give you the aldehyde. But what is that something? That you need to tell me. Getting my point? So what something is which is formed, and that whatever is formed, Jovita, in the middle is same as that of the reaction of the product which you observe when you react the aldehyde or a ketone with ammonia derivatives. This is ammonia derivative hydrazine. And what happens initially is that you remove H2O. Is it clear or not? You remove H2O. So you end up with this compound, hydrazone. Is it clear? Hydrazone, when you treat it with a base, it is converted to alkane. NN2. So this is the same reaction which we do in Wolff-Kishner reduction. This is Wolff-Kishner. And it proceeds via formation of hydrazone. Any doubts on this?
No, sir.
Jovita and Jaslene, I hope it is clear because a lot of questions are being
Yes, sir.
asked. Okay, good. Okay. So let's move on to the next question. C double bond OCH3. Okay, if you treat it either with the Clemenson's or with the Wolff-Kishner, this reaction, this COCH3 is going to change to either you do Clemenson's or Wolff-Kishner. Aldehyde, either you take aldehyde or a ketone, both change to alkane. Okay. So alkane is going to form for this aldehyde or a ketone. Which is the suitable reducing agent? That you need to tell me to carry out this conversion. Lot of questions are being asked in this pattern. This I hope the question you understood. X can be it can be carried out by Clemenson's reduction. It can be carried out by Wolff-Kishner reduction. It can be carried out with LiLH4. Which option is correct? I hope the question is clear. Gyovita, is the question clear?
Yes.
Which is the appropriate reagent? They're asking. One thing is sure that all of these are reducing agents. Okay, all of them are reducing agent. All of them are causing reduction. Okay. So, but which is most appropriate, because this is a single correct choice. Okay, all of them can't be correct. Only one option is correct. You need to convert the double bond O to alkane. But there is one more thing which you will notice, that the ether has remained, the ether at the bottom. Okay, that has remained as ether only. You can see this bottom group is same because that is not getting reduced. Okay, a double bond O will get reduced. Okay, so you need to tell me which is the right option.
Option D.
Option B, yes, absolutely correct. But why it is the right option? It can be Clemenson, it can be Wolff-Kishner. Both can fulfill the purpose. So what makes you think that the B is correct, and that is the answer? B is the answer. The reason is the ether. The ether has remained as it is even after the reduction. You can see clearly. And that ether should not get disturbed by reduction. Reduction we are doing for ketone. But that ether should not get disturbed. Got it? And if you take acidic medium, the ether may break as CH3Cl. So we should not use Clemenson. We can use Wolfishner. LH and H2NI, they will not make, they give you alkane, they will give you alcohol. Okay. So C and D are not appropriate. I hope this question is clear to all of you. Very important question, because nowadays the questions which we are getting are of this type. Jovita, is it clear? Jaslin? I hope lot of questions in many examinations you can see are of this type. Let's move to the next problem. This problem is related to intramolecular aldol condensation. That is the main part of this problem. But I have given ozonolysis and followed by KOH heat. Clear? So the structure of B will be so which option is correct? This is the very common question where you get two aldehydes by ozonolysis. This is reductive ozonolysis, which cut the double bond, has double bond O, double bond O. And when you have two aldehydes within the same molecule, you carry out aldol condensation or Cannizzaro condensation, Cannizzaro reaction, depending upon the nature of the aldehydes. If they possess alpha hydrogen, the reaction will be aldol condensation, and if they do not possess any alpha hydrogen, the reaction will be Cannizzaro. I hope it is clear. So which of the following is the correct answer to this problem? And all may look very similar because they are very close to each other. So we need to actually look into the structures and check which is the right answer. So question, I hope is clear to all of you. First, try to sort out the reactions, whether you are comfortable with the reactions or not. So what is the structure of A? Yes, Yogita, what you will do with A? This is ozonolysis. Gasoline, Yogita, help me out to solve this problem.
Option
Option A, yes, correct answer. So how we are going to do it? First, we are going to cut the double bond. Clear? If you cut the double bond, you are going to get double bond or double bond. Okay, that's what the ozonolysis is. So look for the fragments which are separated by cutting of the double bond through ozone or through ozonolysis. Okay, and now will this compound can undergo whether this compound can undergo aldol condensation? We have to check whether it contains alpha hydrogen. The answer is yes, it has alpha hydrogen. So connect this carbon to double bond O, remove water, and you will get this as your answer. Yubita, I hope this is clear to you. Jaslene, tell me quickly. Any doubts on this? Intramolecular aldol?
No, sir.
And whether it is intramolecular aldol or Cannizzaro, you need to check both the aldehydes. Okay, and you need to check whether the aldehydes are having any alpha hydrogen. Let's say in the next example, which is also a very famous question being asked at a lot of places. I take two aldehydes, or I can write them in this. Yeah, do any one of them possess alpha hydrogen? Any of the aldehyde? Yes or no? The hint is the both do not have any alpha hydrogen, because if you try to check the benzene, already there are bonds completed and no alpha hydrogen is present. Okay, so what is the structure of Y? But you heat it with base, then you put acid, then you do the hydrolysis, acidification, and the heat, which led to the removal of water. Yuvita, Jaslin, I hope everybody can see the question.
Yes, sir.
So base and heat can lead to aldol or Cannizzaro. Okay. This is a very famous reaction, not only involve aldehyde ketone, but carboxylic acid and its derivatives. So what will be the answer, Jaslin? Option A, B, C, D, which is the right option? First, you can tell me what is X. Try to figure out X. This is, I can give you a hint, because none of the aldehyde possess alpha hydrogen. So X is going to be the Cannizzaro, product of Cannizzaro reaction. Clear?
Yes, sir. So one second.
So Cannizzaro, intramolecular Cannizzaro. That also we should keep in mind, because the molecule has two aldehyde and none of them possess alpha hydrogen. Unlike the above example, which was intramolecular aldol, this is intramolecular Canizaro. So Canizaro, how we write the product? Very simple. Canizaro is much more simpler than aldehyde. You oxidize one of the aldehyde and make it carboxylic acid, and you reduce another one. So this is going to be the product of Canizaro. Jovita and Jasleen, do you agree with the structure of X which I have written? Any doubts on this?
No, sir.
Okay. So yeah, Jasleen, we are just close to the answer. So now if you heat alcohol and carboxylic acid, what happens when you heat alcohol and carboxylic acid? You might have studied from your class 10th also, because that is a test for alcohol, that is a test for carboxylic acid, and it gives a compound which has a fruity smell. What the functional group is known as? It is known as ester. Is it clear? What happens when you heat carboxylic acid and alcohol? Water is going to get removed. So just remove the water. Okay. This is intramolecular esterification because we are not adding any alcohol. So this is going to be the right answer. Clear or not? Any doubts in this? Jaslyn, clear or not? Jovita?
Yes, sir.
So do keep this in mind because a lot of questions have been asked on the same pattern. Let's move to the next problem. Next problem. You have to identify a product, okay, of the given reaction. And this is related to mixed problem aldehyde ketones. Okay. The question is asking about the major product of this reaction, CH3 MgBr, and this is none other than the addition of Grignard on polar pi bond. You have taken 2 moles. Then you have taken H3O plus, and then you have taken concentrated H2SO4. So which product are we going to get? Okay. So let me write the product quickly. The product will have a part of the parent molecule will still continue into the product. So I will just copy it. You can see the problem. Very easy one. Addition of Grignard. So what is the right answer? Jovita, Jesslyn, tell. I hope you can do it quickly. Add CH3, but do keep in mind that there are 2 moles, right? So you have to add 2 moles. Is it clear or not?
Yes, sir.
So which is the right option? Add CH3 MgBr where it can be added. This is the nucleophilic addition of aldehyde and ketones. So just check where it can be added. It can be added on polar double bonds. This is delta plus, and this carbon is also delta plus. Why? Because this is connected to nitrogen and this is connected to oxygen. Clear? I hope you can see it. Now we need to add CH3 MgBr 2 moles. But there are all other double bonds which are not polar. These two double bonds are only polar. Okay. So you need to add CH3 MgBr to this. I hope I am clear to all of you. So just add them. Is it clear or not? Any doubts in this? Hmm? Just a second. So what will happen if you add CH3 MgBr? To a ketone, yeah, just name, to a CN nitrile, what will happen? What are we going to get when we add CH3 to CN? Option A and option B are the two very close contestant. But CN will not remain CN. That will change to ketone or aldehyde. So option A or option B? Jivita, can you make out which is the right answer? I have given you two options. Answer is either A or B. CH3 is delta minus, right? And when
Option B.
yes, option B. Why option? Why option B? Correct. Absolutely correct. What's the reason for option B? Tell me. It is because that double bond and the CH3 is going to add here also. That CN will give ketone, so COCH3, COCH3. And when CH3 will be added to this will become a tertiary alcohol. Okay. And look at the last step. If you look at the last step, you will observe that it is heating with concentrated H2SO4. Okay. In concentrated H2SO4 dehydrates water, eliminate alcohol and OH and H. And the water is getting dehydrated to form the double bond, but the double bond is going to form towards the side of the benzene. Okay, this double bond is correct. This is away from the benzene. So this is not correct. I hope it is clear. Any doubts in this? Got it. So very important question, very good question regarding the addition of aldehyde and ketones. Okay. Let's discuss another problem. Related to carboxylic acids preparation. Okay, the carboxylic acids, how they can be prepared? They can be prepared by various methods, as we have discussed in our regular class. In the first reaction, I have given the reagents, and you need to tell me the products. In the second reaction, the product is missing and the reagent is also missing. So which option is correct? So which option is correct? So first, always try the first set of reaction, and this is because all the reagents are given. You can predict the products. Okay. So CH3Cl AlCl3, it is the Fieldcraft alkylation. Cl minus will be taken out by the AlCl3. Or if you want to follow the quick approach without getting into the mechanism, remove HCl and connect the methyl group to the benzene. And the second step is the oxidation. Okay. Oxidation, that all the alkyl side chain get oxidized to COH. So that Y is benzoic acid, this is correct. But what about P? P is the chlorination. of benzene. Here also you can follow the same approach which you have followed above. If you don't want to get into the mechanism, remove HCl and connect the Cl and the benzene together. This is P. And if you want to get it converted to Y, you must use magnesium ether followed by, this is the increase in number of carbon atoms, okay, CO2. So this whole set of reagent come under Q. Clear? So this, I hope, is clear. Very, very important questions regarding the conversion. Do keep this in mind. Okay, let's have it in the next class. Okay, so